So this is another of our Bio440 lab videos on Chapter 20 protists, and we've been using our protist worksheet. So the previous videos we went over free living, protozoa, euglena, paramecium, amoeba, proteus. The second video was on intestinal protozoal parasites. We talked about Entamoeba histolytica, giardia, and then we talked about the bonus sexually transmitted protozoal pathogen Trichomonas. The third video was on Trypanosoma cruzi causing Chagas disease or American Trypanosomiasis. This is a vector-borne disease. And so this video will be on a cousin of Trypanosoma cruzi that we're going to use a generic name, Trypanosoma brucei. There's actually two subspecies which we'll mention. Trypanosoma brucei is also vector-borne. The vector is the Glossina or tsetse fly. Trypanosoma brucei causes African Trypanosomiasis, also known as sleeping sickness. So that's what we'll do on this video. So let's see if we can find our little flagellated Trypanosoma brucei. In your prepared slides, they're much better for Trypanosoma brucei than for Trypanosoma cruzi. The trypanosomes are much more numerous. To me, they appear bigger or longer, so they're easier to identify. So again, you'll be looking at blood smears, and I'll just go through kind of the natural history of the life cycle here. Get down. All right. So the detail I'm about to mention, you need not worry about this on the lab exam, but just so you have a few more specifics that might be of interest if you're actually traveling in Africa or if your patients have a history of living or traveling in Africa. So there's two subspecies or two strains of Trypanosoma brucei. The first one is called Trypanosoma brucei gambiensa, and the second one is called Trypanosoma brucei rhodesiensis. Again, I won't ask you this, folks, but Trypanosoma, we'll call it gambiensis. The reservoir are humans. In contrast with the Trypanosoma rhodesiensis, animals are the reservoirs, so cattle. This can be really devastating in domesticated cattle. And then wild animals, such as antelope, can act as reservoir. And my understanding is the Trypanosoma rhodesiensis, a lot of the wild animals are better adapted to coexist with the Trypanosoma, whereas domesticated cattle often are killed by the infections. So the life cycle is, the way we get infected is that if an infected Glossina fly or tsetse fly bites us, one that's already been infected through a previous blood meal, when the Glossina ingests the blood meal that contains the trypanosome replicate in the intestinal tract, and then they migrate to the salivary gland. So when the Glossina bites us, they always inject some saliva, and the saliva might act as an anticoagulant. It will inject the Trypanosoma brucei as it injects us. They have these vicious slashing mouth parts, kind of like scissors. So the trypanosomes are injected into the skin with the saliva. They then travel in the blood. They multiply in the blood. And what's really fascinating is that the Trypanosoma brucei, they undergo this process called antigenic variation, in which through gene shuffling they can change their surface glycoproteins, and apparently there's over 100 different antigenic types. So every 10 days they can change these surface glycoproteins. Now the reason that's important is our antibodies target those glycoproteins, and one of our protections is we make antibodies against the surface glycoproteins. The antibodies cause a agglutination of the trypanosomes and eventually will help to destroy them. Excuse me. But because every 10 days the trypanosomes can change those surface glycoproteins, that means every day we have to start a new immune response to try to kill them. So this is a way to avoid evade our immune response, and so that makes it really challenging. Because of this continual antigenic variation, we can spike fevers every 10 to 2 weeks. And again, as our antibodies start destroying them, the fever goes down, but the antibodies can't kill all of all of the trypanosomes, because some will have that antigenic variation. So then those that survive will multiply, and then another 10 days to 2 weeks will have another fever spike. So we can have these intermittent fevers. So the trypanosomes are multiplying in the blood. They can then reach the lymph nodes and multiply in them. They can cause lymph node enlargement. They can then invade the brain, and this is where it gets truly serious and very difficult to treat. So it's with the invasion of the brain that we see the common name, sleeping sickness. So the patient can develop a coma, and the mechanism is there's demyelination, a demyelinating encephalitis. So the myelin sheath on the neurons of the brain are demyelinated, and that's going to decrease nerve impulse transmission. So as a consequence of that demyelination, some of the clinical signs and symptoms would be headache, insomnia, the inability to sleep, mood changes. You might have muscle tremors, slurred speech, apathy, like you just don't care anymore, somnolence, meaning you're just sleepy all the time. You can then enter into the coma. And to me, what was really interesting is that usually what kills you is a pneumonia. So I'm wondering, with decreased nerve impulses, excuse me, you get an aspiration pneumonia. So often death is through the pneumonia, not directly through the damage to the brain. And again, folks, these are just some little details that you wouldn't have to know. Initially, there'll be a lesion, an ulcer where the Glossina has bitten the patient, and then again the intermittent fever, the lymph node enlargement. Apparently, the lymph nodes at the back of the neck, the posterior cervical lymph nodes, will become enlarged, and then you enter the encephalitis stage, which we had just described. This, again, folks, it's just detail. Excuse me. So African Trypanosomiasis, it's endemic in sub-Saharan African regions, which are the natural habitat for the tsetse fly, the Glossina. Both sexes of the flies can take blood meals. Both sexes of the Glossina can transmit for their entire 2 to 3 month lifetime. And you might wonder why we're saying, both sexes. Well, we'll see with Plasmodium Malaria, it's only female Anopheles mosquitoes that will transmit it. So just kind of a interesting factoid. Trypanosoma gambiensis is endemic along waterways of Western Africa. Trypanosoma rhodesiensis is found in the more arid regions of East Africa, and you can find both species of trypanosomes in Central Africa. Again, factoids you don't need to remember, you guys, but Trypanosoma gambiensis tends to have a lower grade chronic course over a few years. In contrast, the Trypanosoma rhodesiensis, it has a more acute, rapid progression, and it can be fatal within months if not treated. And I think, folks, with that, then we'll close this video. Just a reminder that taking your patient's travel history or where they've lived will be really important. As what you would want to remember is that if your patient hasn't visited endemic areas of Africa, if they haven't lived there, you should not suspect that they'd be suffering with African trypanosomiasis. In contrast, again, important to have the travel history of where folks have lived if you suspect Chagas disease or American trypanosomiasis. So again, the patient history is going to be really important. The next video we'll do, folks, will be on Plasmodium Malaria, and that is also vector-borne. And we'll see that Plasmodium, as we mentioned earlier, is going to be transmitted by mosquitoes of the genus Anopheles. And it's only the female Anopheles mosquitoes are the blood feeders. So it's only the female Anopheles mosquitoes that are going to transmit the Plasmodium. Okay, so that'll be our next video up.